Okay. So we are going to look into the polar coordinates.
Mm-hmm.
Then we will move to polar functions. Polar coordinates. Now, as we have seen that to specify any position, we can use a coordinate system. We can use
Mm-hmm.
one reference system. Normally, what are the coordinate system that we use? The most popular one is rectangular coordinate system. Rectangular coordinate system. In this system, we use X, Y, and Z, three values to pinpoint or to locate the position of any object. Then another coordinate system is another reference, you can say reference system is polar. So polar coordinate system. So we will write polar coordinate system. In polar coordinate system, we have two variables. Just like in the previous one, we had three variables. In polar
Mm-hmm.
coordinate system, we have two parameters. One is r and another is theta. We will discuss more about it. Then third one is we can use cylindrical coordinates also.
Mm-hmm.
So cylindrical coordinate system. Then we have spherical coordinate system. Spherical coordinate system. We have log polar coordinate system. So all these coordinate system, and there are many others also. So these are some advanced version of coordinate system that we usually study in undergrad or master's program. Right
Mm-hmm.
now, we are focusing only on rectangular coordinate system and the polar coordinate system. Okay.
Yes.
So what is r and what is theta? So polar coordinates means any position, any object, we specify two parameters r and theta, where r is the distance of the object, means the object whose location we want, distance of the object from pole. Pole pole is the center of the polar coordinate system. It is, you can say, it is equivalent to origin of rectangular coordinate system.
Mm-hmm.
Then theta. Theta is the angle made by line joining the pole to that object position. So angle made by line joining the pole to object with reference axis. And it is always calculated in counterclockwise system. Always.
Mm-hmm.
So that means in polar coordinate system, we will have one reference axis and we will have one pole. Okay?
Yes.
And based on these two, we have to specify our r, that is radius, and the angle. Okay.
Mm-hmm.
So let us take this as pole and this is the reference axis. Don't write any arrow sign in reference axis. It is not x-axis, it is not y-axis where we have to show positive x-axis, negative x-axis. So don't write
Mm-hmm.
any arrow sign. Just one dot
Okay.
which represents the center or pole of the coordinate system and
Yes.
one reference line. Normally reference line extends from the pole towards right hand side.
Mm-hmm.
Don't take this one as reference axis. The reference axis you have to take from the pole towards right side.
Okay.
Okay? Now, so this is the pole, this is the reference axis. And now we want to represent, let us take this point here. So what we will do is we will join this point with this. We will calculate. So if this is O, this is P, we will calculate this distance OP, which is R. Let's say this magnitude is R. And also we will calculate this angle. So this is theta. So we can say that the position of or the polar coordinate of this point P is R theta.
Okay.
Now, say for example, if we say that if we want to locate one position as 2 and 60 degree, it means that what we will do is we will first show the pole. This is the reference axis. Draw 60 degree. Just take 60 degree angle. Cut at this one. So let's say this is the point. This is the point P, which is making 2 units, and this angle is 60 degree. So this is how we represent the polar coordinates. Now here we have to learn how to convert polar coordinate system to rectangular coordinate system and rectangular coordinate system to polar coordinate system. That we have to look into. So we will look into conversion. So this is our center. Let's say O. This is our reference axis. This is the reference axis. Take any point P here. You drop one perpendicular like this and join this one. This is R and this is theta. So polar coordinate for this point is R theta. Fine. Now what you do? Let us take the rectangular coordinate axis at this point, at this location, such that origin is coinciding with the center of the polar coordinate system. So we are showing polar coordinate system and rectangular coordinate system on the same graph. Okay? So where our pole was situated at that point, we are taking our origin of the rectangular coordinate system. Now, you drop one perpendicular line here and again one perpendicular line here. We know that this is y-axis and this is x-axis of our rectangular coordinate system. So this one is, let's say, Rx and this is Ry. Now using the trigonometry, we can write Rx divided by R is equal to cos theta. So that will give us, that gives us Rx is equal to R cos theta. Similarly, we can use the trigonometric ratios definition to find out this ratio. Ry over R is equal to sine theta. That gives us Ry is equal to R sine theta. Now, what is Rx? If you look into the rectangular coordinate system, Rx is nothing but x coordinate. It is the x component. And this is the y component. So we can write it like this, that x component is given by R cos theta and y component is given by R sine theta. This is one important relation between our rectangular coordinate system and polar coordinate system. Okay?
Yes.
Good. Now we will see some example. So if R theta is given, we can calculate x and y by using this. See, for example, if the question says that convert 260 degree. So this is one polar coordinates of any point. So convert 260 degree to rectangular coordinate system. Rectangular coordinates. So this is polar coordinate system, and we want to convert it to rectangular coordinate system. Means rectangular coordinate system is what? We have to find out x-axis, what is the x component, and what is the y component in rectangular axis. So we will do like this. This is our question. So our answer will be pretty much simple. We know that x is equal to r cos theta, and also we know that y is equal to r sin theta. Y is equal to r sin theta. So here we have r given as r is 2, theta is 60 degree. So we will write 2 cos 60 degree. That will give us 2 times 1/2. Is it okay?
Yes.
That will give us 1. So we will say
And
that x.
we use this unit circle to find the what cos is.
Yes. To get the value of cos 60 or sin 60, we have to take the help of unit circle. And if the angles are not popular angle, or if the angles are not available in the unit circle, we have to use the calculator to do this.
Okay.
So x coordinate will be 1, and here y is equal to 2 sin 60. Can you tell me what is sin 60?
Sine 60 is √3/2.
Perfect. So 2 multiplied by √3/2. So this will cancel out. So we will get y is equal to √3. So our rectangular coordinates are 1, √3. Okay. So this type of question you can expect where you will be given polar coordinates and you have to convert to rectangular coordinates. The reverse one we have not seen, that we will see after some time. Now I'm giving you one more question. You can just try to convert from polar to rectangular.
Okay.
So question is this: convert. So our point is, let's say a 530 degree to polar to a rectangular coordinate system.
Okay.
Rectangular coordinates. Yeah, try to do it. And then one more we will do here. Convert. We can say 290 degree to rectangular coordinate system. So tell me for the first one, how you are doing. So x coordinate and
So
y coordinate you
x
want.
so r and theta. So r is 5 and theta is 30. So when you're solving for the x coordinate, you do x equals r cos theta. So that's equal to 5 cos 30, which is equal to um
Cos 30 is how
5
much?
5 times √3/2.
Perfect. So you can write 2.5 √3. Okay. What about y?
1 second. So y, it's x, y is equal to r sine theta. So that's equal to uh 5 sine theta, or 5 sine 30. And then that's equal to 5 times 1/2. So that is just 2.5.
Perfect. So our coordinates are 2.5 √3, 2.5. Okay, good. Now do this one.
Okay.
So convert 2, 90 degree to rectangular coordinate system. Instead of rectangular, you may be given word Cartesian.
To what?
It
The
means
word what?
Yeah. So instead of rectangular, you can also expect this word, this term, Cartesian. So question may be asked that convert this 530 degree to Cartesian coordinate system.
Mhm.
So it means that you have to do like this. Same thing. Rectangular coordinate system and Cartesian, we will take it equivalent. Okay. So tell me what is the rectangular coordinates you are getting, Cartesian coordinates you are getting
I'm
here.
almost done. I'm almost done.
Mhm.
I got 0, comma 1.
0, comma 1. That is correct. Because x is equal to 2 cos 90 degree, but cos 90 degree is 0. So it will be 0.
Mhm.
And y is 2 sine 90 degree. So that will be 2. So our coordinates are, Cartesian coordinates are 0, comma 2. Okay. So till now
Yes.
we have seen the conversion from polar to Cartesian. Now we will do the reverse one. So let us see how to do the reverse conversion.
Yes.
So let's say we have been given a rectangular or Cartesian coordinates as xy. This is given. Xy is given. Okay. Now we know
Mhm.
that x is equal to r cos theta.
Yes.
Also we know that y is equal to r sin theta. If you
Yes.
square the two terms, if you square the two terms and add it, you will get like this: x squared plus y squared equals. So when you square the x, you will get r squared cos squared theta, and when you square the y, you are getting r squared sin squared theta. Now you can take r squared as common, so this will become cos squared theta plus sin squared theta. Now we know that as per trigonometric identity, cos squared theta plus sin squared theta is equal to 1.
Mhm.
So we can write it to be r squared. So that means our one relation is x squared plus y squared is equal to r squared. So by
Okay.
using this, we can get the value of r. See, you have been given xy. So how to calculate
Yes.
r? R can be calculated by using this formula.
Okay.
Okay. Now, if we divide these two, if we divide uh, this and this, so y over x, if we do, we will get r sine theta, we will get r sine theta over r cos theta. That
Mhm.
means we will get, let me write here, r sine theta over r cos theta. So r will cancel out and you will get tan theta. So you see from here, we will get the theta also. So we will write theta is equal to tan inverse y over x. Now, by using this formula, we will get theta. That's what we need. We need r theta. So xy is given and we need r theta. So we will use these two expressions to find the r and theta. Is it okay?
Yes.
Let us see one example. We will see one example. So yeah, first you note it down, then we'll
I
see.
did. I noted it down.
Okay. So let's say question is saying that convert uh, 4, 3. Convert 4, 3 to polar coordinates. So we want to convert 4, 3 to polar coordinate system. So how to do? Already it is given x. It is already given y.
Yes. So we solve for r first, right?
Yes.
So x squared plus y squared equals r squared. So
Mhm.
that's 4 squared plus 3 squared equals r squared. So that's 27 equals r squared.
Ah, no, no, no. Do it correctly. 4 square plus 3 square, how much?
Or 25 squared, 25 squared. I don't know what I said. 25
It is,
squared.
no, not square.
20,
It will be
or not
25
square, it's
only.
25. So you square root,
Yes.
right?
Yes. So
Okay,
r
so
will
then
be just 5. Don't take minus sign. Just take r is equal to 5.
okay, so R is 5. So now we have to calculate for
Theta.
theta. So
Tan
it's
inverse
inverse tan. So that's
y. First it will be y and then it will be x. Remember, don't do opposite. So
mhm.
tan inverse 3 over 4.
Would you put that in the calculator?
Yes. Tell me what you are getting.
I got 0.635
0.635. You
or
change it
64,
to degree.
64, 643.
No. You
Oh, to
change it to
degree.
degree. Yes. You are telling me in radian. You just convert that one to degree. Just check it.
It's the pi thing. It's like pi over uh 100,
Huh?
right? 180.
No. Tan inverse 3 by 4. If you do it in a degree, how much it is coming? Just check.
I don't know how to convert my thingy to degrees.
Okay. There is a mod option. You can convert it.
One
Okay.
second, I'm looking.
Uh, you can use, you can change the mod. You'll get it. Mm,
One moment,
you,
let me quickly search it up.
uh, okay, let me tell you this one. So tan inverse 3 by 4. Okay. Can you type there in your calculator? You will get to know whether it is in degree or in radian. Just you try to.
My thing is in radian, but I don't know how to set it to degrees.
Okay. Anyhow, you can. We will discuss this after some time. So this is
Okay,
37 degree. Okay. It
37
will.
degrees. Okay.
Yes, it will come to 37 degree. So that means our polar coordinates are corresponding to 4, 3 is our polar coordinates are uh we will write this one 5 comma 37 degree. So technically speaking, whenever you write polar coordinates, don't write it in degree, better to write it in radian. That is the standard format. Write it in radian. Okay. But for
Oh,
easy
I
understanding,
I figured out how to convert my thing to degrees.
perfect. So how much you are getting when you do tan inverse 3 over 4?
I got 36.869.
Perfect.
So
Yes. Yes. Good. Now convert this one. So first note it down. Then we will see the another question. Shall I raise this one?
yes.
Okay. Now do this one. Convert. Okay. Now it is 3, 4. Convert 3, 4 to polar coordinate system. Yeah, try to do
Okay.
this. After this, we will look into polar equations and what does that equation mean, and what are the equivalent equations in Cartesian, that we will
Mhm.
see. Okay, so
So
tell.
R is equal to 5,
Yes, correct.
and then we have
Theta is.
one second.
Mhm. Now you will get the correct answer because now it is in degree.
Yes. It's it's one second.
Mhm.
Yeah, so it's 53 degrees.
Perfect, correct. Now
So the
do this.
coordinates are
Yes,
5 comma 53.
perfect. But by default, remember here whenever we write in degree, we have to mention this particular symbol. If you don't
Yes.
write it, it means by default it is radian.
Mhm.
Okay, so always try to put this value, this
Yes.
degree sign. Otherwise, it will be deemed to be pi. It will deemed to be radian. Okay.
Yes.
Now, can you convert 1 0 to polar coordinate system? Do this.
So 1 0.
Hmm.
So R is equal to 1, correct?
R is equal to 1. That is correct. Good. One.
So I got 0 degrees.
Correct. This is 0. Theta
Hmm.
is equal to 0 degrees. So our
Yes.
coordinates, our polar coordinates are 1 0.
Hmm.
Now, if you look into this, you see this is our pole and this is our reference axis. Now, at this point, obviously, if any point is lying here, its
Hmm.
its Cartesian will be 1 0, but its polar coordinate will be, let's say this is r
Yes.
and 0. If you go to this point, if you just revolve about 90 degree, at this point, can you tell me what will be the Cartesian and what will be the polar?
So the Cartesian and the polar.
Yeah.
1 second. So Cartesian would be
Take r is equal
z-
to 1. Okay. Take r is equal to 1.
okay. So we want the point, this point, right?
Yes. Yes.
Okay. So it'd be 0 1 for the Cartesian, correct?
Yes. And for pole, for polar
Would it
coordinate?
be? It would be 1 comma. Uh, would it be 90?
Yes. Correct. Good.
Hmm.
Now let us move little bit more here. At this point, tell me what will be the Cartesian and what will be the polar coordinate.
So Cartesian would be -1 0.
Negative 1 0 and polar?
It would also be 1, but it'd be 180 degrees.
Correct. It will be 1 pi. Very good. Now come to this point again. At this point, what will be the your Cartesian and what will be polar?
Cartesian would be 0 comma -1.
Yes. And polar?
Polar would be 1 second. It'd
Hmm.
be 270.
So it will be 1 and 270. So 270 degree. Very good. Now again come back to the same position. Means after completing one rotation, come to this point. So earlier it was 1010, our starting point.
Hmm.
Now after doing one complete rotation, tell me what will be the Cartesian now
It'd still be 1 0.
and polar?
It'd be 1 2 pi, or just
Correct.
pi, or
No,
not
2
pi. I mean,
pi.
or
2 pi.
just
2 pi.
okay.
Now you see one thing. If you again go to this point after completing one rotation, Cartesian will remain same, but polar will continuously change because polar coordinates angle will continuously increase. But your Cartesian will go on repeating itself.
Hmm.
In every 2 pi, it will repeat itself.
So would your polar coordinates, so like eventually if it goes like
Infinity.
720 degrees, it'd be 2 4 pi, and then
Yes.
6 pi. Okay.
Yes. It will continuously go. So polar coordinate will continuously go.
Hmm.
Now here we are assuming that its radius is radius is constant. Okay. So, but Cartesian will repeat itself. Okay.
Yes.
Now, next we will see some important equations in polar coordinate and your Cartesian coordinate.